Hello guys, so we're going to continue the same series again. We are now going to start with missing data, and now I'm going to head into areas which I'm not quite familiar with down here because I haven't really gone through them before. I'm still a novice in all these things, so maybe I'll learn some new stuff. Maybe I'll help you guys also understand it. So let's get started. Pandas primarily uses the np.nan to represent missing data. We've discussed this before. np.nan is basically the none value in NumPy. It is by default not included in computations. Okay, so this basically means that, for instance, if you have a list of ages, you did a survey to find out the average, and you need to find out the average age, and say 10 people out of 100 did not disclose their ages. So if you include a zero in place of their actual age and take them into consideration in the total number of people, then you'll get a wrong estimate of the ages. So rather than that, if you have an np.nan value, it will not be included in, say, the computation of the mean or the median, and so it will give you a more accurate data of what your average age is. So reindexing allows you to change, add, delete the index on a specified axis. This returns a copy of the data. So basically, if we try to do this in our own Jupyter notebook, so first we'll read df once again, and now let's do this. Df1 is going to be a new notebook where we are going to do the following operations in df. Um, let's just do them and then print out df1. Yeah, so first of all, we have the index dates from 0 to 4. So this is the 0 index, first index, second index, third index. Fourth is not being included here. So we have the first four rows. As we had specified the index for those rows only. Dates is the date time index. Now columns are the list df dot columns. So basically list df dot columns returns a list of all the columns. So you're getting all the columns here, and plus e just adds the e column once again. So here you are getting the e column added once again towards the end. You can see a list of df columns here, and you'll get the list of df columns. Okay, so that makes sense. Now let's do this as well. So first we'll print df1 once again, and now uh, yeah, so the change happened. So there is df1. Now we did the following thing. We said dates 0 to dates 1, and to be set to 1, right? So dates 0 is this, dates 1 is this, and we had given the column to be column E. So this is column E, and column E occurred twice. So column E has been, wherever column E occurred has been changed to 1. So maybe you want to see what happens if we add column G as well. So you added column G as well, and now um, okay, so it did not work as intended. And why is that? Maybe you need to pass a list or something. I'm not quite sure here. We have E and we have G. Yeah, so you needed to add them as a list. And I got to learn that if you add them like this, they just add a new column and the rest of the values become none. So learn something new today. And now let's go ahead to drop any rows that have any missing data. We can do this. So basically what this does is, again, we had df1 right here, and now we use drop na. Drop na just drops rows which have na, and any means it will drop any row which has even one none value. So these have only one none values are and they have been dropped. If we switch this to all, I believe it will only drop a particular row if all the values of the row were none. So in this case, we had no such row, so none of them have been dropped. Okay, so filling data. So as the name is quite suggestive in itself, so we can just do this, and you can see fill NA has filled these two none values with the value 5. You can also use other values as well. And just to be clear, if you do df1 once again, these values are not being saved. So to save them, you just need to do this: rewrite df1. Sorry, there should be an equality sign here. And now if you look at df1, the values have been changed. There is a in place is equal to true parameter in some places. I'm not sure if it's there in this. Yeah, so in place is equal to true is there. So what that does is, instead of doing this, you can just do in place is equal to true, and it will uh, do the change in the df1 data frame itself. You do not need to save it again into df1. Okay, so now let's go ahead to get the boolean mask. Yeah, basically pd dot is na returns a boolean list, and if you give df1, if there is any na values, it will return a false. Like here there are none, so uh, it returned all to be false, as there is no all of them have some value, so all of them are not na. So is na is false, they are not na, so is na is false. You can do a simple trick: use this symbol and it will change it to if it is not na. So it is not NA for all these things, so these are true. You might be wondering why 0 is not NA. NA only is np.nan in this case, I believe. There might be some other keywords as well, but 0 is not being considered to be NA. To understand the difference, you might uh, take the example of the survey once again. When someone refuses to say give their age, they do not say my age is 0. They just write a NA in that place, right? So in similarly, 0 might just be a value in some survey or some data table. Like for instance, you are taking the average salaries of people, and you have two students in there who are not yet earning, so their average salary would be 0, right? So you can use 0 instead of na in that case. So now let's have a look at operations, because I guess we have, yeah, so the boolean mask where values are none. So operations, see the basic section on binary ops. We'll look at that in a later video, because right now I'm just focusing on the 10 minutes to pandas uh, section. So now let's go ahead and look at stats. Operations in general exclude missing data, like I mentioned, perform a descriptive statistic. So let's just do it. First, let's just print df. We have df here, and if we do df dot mean, it has computed the mean of all the places where there were numbers. So for instance, column F had characters, so there is no mean for them. So it has not returned any value for F. We have E and then G. So this is df dot mean. So it gives a basic idea. For instance, you might have a age column, or you might have a salary column, or you might have some other column where a mean gives you an overview of what type of people had participated in the survey. Mean can often be misleading, and that is why we use other things as well. So this is mean misleading is quite a thing, so you can read up on it as well. Now let's look at df.mean1. So it does the mean along axis now. So let's just do that. So basically it has computed the mean of these values right here. So let's do that ourselves for once and just check what happened. So we have a nan in here, we also have a in here, we have these values. So let's open the calculator. Our first value is 0, second is 0, third is 0.967331. So 0.967331. Then we add their 5, and then we subtract 0.428150. So 0.42815. So we get this value, and then they these 5 are going to be considered as numbers, right? So we are just going to divide this by 5 and we get 1.107, which is what it is here. So now from this you can see nan is not being included, as they had mentioned in generally excludes missing data. Also, this f column does not have a number, so it is not being included automatically. So now let's go ahead. One is just axis 1. I would prefer if it would have been written something like this: axis 1. Axis 1 are the rows, axis 2 are the axis 0 are the columns. Sorry. Now we have the data column wise. You can also use um, things like this, I believe. Columns. Yeah, columns and rows. And I often find this much better because I often forget what 1 was and what 0 was, so I have to look that up like I did in a previous video. So now let's go ahead. Operating with objects that have different dimensionality and need alignment. In addition, pandas automatically broadcasts along the specified dimension. Okay, so let's just look at this series pandas.series. We are familiar with that. 1 3 5 np.nan 6 8. Index is equal to dates. Shift 2. Okay, let's do this for ourselves. Let's do a S1 as well, which is only this stuff without the shift. So basically let's just print out S1. So S1 is as expected 135 nan 68. Now let's print out S. So S is 135 nan 68. So okay, so I had reassigned S here. That's what I was thinking. So you can see shift 2 basically did do something along the lines of shifting 135 down, and nan is now 2 places down, but the new values which have come up are now nan. So 6 and 8 did not go up, they have been removed, and the values which we did not have any, because we did not sort of give anything to fill in the places for the shifted down entities, so they have their a nan value has been put there. We can say try shift 5 and then do S. So yeah, it does this. Now df dot sub s axis index. Okay, df dot sub stands for substitute, I reckon. Like, but let's just um, have a look at it. Df dot sub get subtraction of data frame and other. Um, what does panda sub operator do? Yeah, sub means subtract. So let's walk through. So we have this. Okay, so this is quite long. Let's just try it out ourselves. If we don't understand it, then if we are able to understand it, then we'll go have a look at that Stack Overflow page. Um, okay, so the problem is again with something with strings, I believe. What about df1? Does that work? Yeah. So let's do this. Shift remains 2, and now we print out s, and now we do the df1 dot sub. Okay, so basically the problem is doing operations with nan values, I reckon. If I print out df1, I get this. Okay, so now if I do something like this, df1, oh sorry, not here, here, let's do it here. df1 dot sub. Let's print out df2 as well here. So basically what it did is wherever there are nan values, they have been substituted there, and wherever there are one, like there was one here, so one has been subtracted from all these rows, two has been, three has been subtracted from all these rows, the row values, five has been subtracted here, and wherever there was a nan, the value has just vanished. So that can give us an idea of what it's doing. It's subtracting, and wherever there are nan values, it's just removing them. So yeah, that makes sense. Now you might wonder which is getting subtracted from which. So this was already a negative. If it would have been subtracted, there would have been something positive. So it would have been become a plus zero point 0.2 and 1 would have been added. But that's not the case. So we can safely conclude minus zero point 0.2 minus 1 is what is actually happened here, and we are getting this. So now let's look at the apply function. Applying functions to the data. Okay, so first let's print out df. I think I might have to drop that f column if it causes errors again. No, it didn't. Okay, so CumSum is basically cumulative sum. Okay, cumulative sum is basically accumulating the sum as you progressively go downwards. So first you had 0, then you added minus 1.5, so we get this. Then you added zero point 0.2, so this value decreased a bit. Then you added 0.14, 0.014, it decreased further. Then you added zero point 0.4, it decreased a bit more. Then you added minus zero point 0.6, so it increased in the negative direction. With string, it happens to just concatenate the string, so A, B, then ABC, ABCD, ABCD, E, ABCD, EF. So the strings basically get added. The NAND doesn't seem to cause a value issue here. The operations have worked fine. 1 remain as it is. 1 plus 2 3, 3 plus 3 6, 6 plus 4 10, and 10 plus 5 15. So this apply function basically is applying this to every single column in this. Okay, now this is also using the anonymous functions or lambda functions, if you are familiar with them. Okay, yeah, as I suspected, this f is causing problems. So now if we go a bit up, as we had discussed earlier, deleting a particular column, deleting a column in pandas. I tend to keep forgetting these syntaxes, df del df column name. So I'm going to remove this column name. So df, and I'm going to remove f here because many a times the string is causing issues. So now there is no f. So now I think it should work. So I'm copying it, and yeah. So basically what it does is it created a lambda function, and for every row it got the largest value and the smallest value and it subtracted them. So the largest value in say the first column is this 0.47 and the smallest value is minus 1.56. So when you subtract 0.47 and a negative sign with another negative sign becomes a positive, so it becomes 2.04 and so on. You can see that. Uh, Next we have histogramming. I haven't ever done histogramming, so I'm just going to learn this with you guys. Um, Yeah, so there was quite a pause there, and there was someone at the door. I had to go and open it. So now let's continue with histogramming. So there is another new series S, which is np.random.randint. So basically, what this does is gives us random integers between 0 and 7, inclusive of 0, and size 10 just tells that we need 10 such integers. So let's just do this and then print s. So this is it, and s dot value counts. What that does is just gives us how many of each are there. So for instance, 0 occurs 4 times, 6 occurs twice, 5 occurs twice, 3 occurs once, 2 occurs once. So basically, from what I can understand is, first of all, it gives the values of the highest occurrence first. For instance, 0 occurred the most number of times. Then if there is a tie, it gives the larger value first. So 6 is given a priority over 5. So we can try to randomize it once again and make sure our observations are correct. Yeah. So when 3, 1 and 0 all occurred twice, it gave preference to 3, then 1, then 0. Yeah. So I could not see anything about histogramming here, but I can understand where they are coming from. In the 10 minutes to pandas thing, they cannot give a detailed explanation of histogramming. So maybe, yeah, we might look at this documentation in a further video where they discuss more histogramming. Now we are left with string methods and merging and stuff. We'll look at it in a different video. I'll end it. It's getting quite long already. And just like all the previous videos, if you like it, just comment, like, share, and all that stuff. Tell me any suggestions, any more documentations you might want me to look at, any more things you might want me to cover in the videos. And just like I mentioned, I am also a beginner. I have really no clue why I got into this. I thought it would be interesting. I still feel it's quite interesting. So let's keep going, and thank you.